Hello, my name is Evgeny Bogdanov. Welcome to our EXA4MIND webinar. The webinar it's about Aquaview and airflow, and I represent a company, Terraview, that is part of the EXA4MIND consortium. EXA4MIND it's a European project that targets to solve the problem of extreme datasets. And Airflow, it's part of a tool set for this project. And Aquaview is using Airflow to deliver soil moisture analytics to clients. And we are going to look at how Airflow is being used and what is Aquaview in this webinar. First of all, soil erosion is a big problem for agriculture, and there are several factors influencing it. On one hand, too much water, it compacts the soil, so the soil becomes too hard for water to penetrate through it, so that the roots of the plants cannot get this water to grow. On the other hand, too little water, it also creates problem because the topsoil might become dead, and that's kind of the effect of the drought on the soil that is also deteriorating the soil. And increase of irrigation cost, it's another big concern to be taken account of in agriculture. So what we've been developing in the last several years, it's a tool called Aquaview. So it's a standalone soil moisture tool, and that I'm going to present and show how it works. And the main, the key advantage of this tool is that it allows to detect soil moisture content without using a big amount of soil moisture sensors that are expensive and can be destroyed during the agricultural operations. And the tool provides daily insights for irrigation optimization. Let's look how this tool is working. What we see here, we see a user interface of the Aquaview. We see a geographical field here in the middle of the screen. And inside this agricultural field, we see pixels which are 30 by 30 meters. And for each pixel, we can see how much, what is the soil moisture in this particular pixel. For instance, in this pixel, we see that it's around 20% of the soil moisture content. And if you go into those ones, it's around 2%. So in this part of the field, the soil moisture content is low, and in this part of the field, it's relatively big. So when the agriculture specialist that takes care of irrigation need to take some actions, they might see that here they would need to add some water, and here the soil moisture content is good, so they don't need to change anything. So what the tool shows to us, it shows soil moisture content that is based on the satellites. And as we know, satellites, they are not passing over each piece of land every day. So sometimes it takes several days before we can get the image. And on top of it, there is a different problem which is related to clouds. As we can see in July 2025, for this region, we were only able to get one satellite image of good quality that we could estimate the soil moisture, which is not enough. And this is why we've built an AI model that is able to estimate soil moisture in more granular data. So it can go up to 1 hour. And also we estimate the soil moisture not only on the top of the soils, but with the depths up to 50, 60 centimeters. And what you see here in the calendar, the green one, it's where we have a satellite path, and the other pink circles, it's where we have the soil moisture built based on the model. So if I click now, so I open and we see now the soil moisture map, which changed. And here at the bottom, we see the time. So we can click on 9 hours and see how the soil moisture is changing. And here on the right, we see also the depth. So we can go and look at the soil moisture content at 30 centimeters depth. So, and as I mentioned before, all this is possible by using AI model that takes soil moisture information that was measured by satellites. It takes weather into account, soil types, and if there are sensors that measure soil moisture in soil, this information also goes into the model, and then the model can do those predictions. And as you might imagine, there is a big amount of data that is needed to to first run those models and generate the results, and also the results, as you can see, there is a big amount of data because for each hour at different depths, we have soil moisture map for this field. So this is how Aquaview is working and what it delivers, and it helps farmers to optimize their irrigation practices. Let's look now at how those things are working. Here you can see the graph. So this is how the soil moisture calculation pipeline works. And as I mentioned before, so it first uses satellite data to generate the soil moisture content, which is based on our proprietary algorithm. And then it uses AI model to backfill the data in time and also in depth. And here on the graph, we see how those things are working. So we have a triggering mechanism. So in this case, for each hour, an AI model will be triggered to deliver the results. So we have an ingesture. We have a third block here that calls planetary computer or any other satellite-based provider to download imagery. And that's the piece that we are optimizing with within EXA4MIND project, because currently it takes a significant amount of time and a big amount of data to be transferred. And we saw a very big improvement in speed and decrease in the amount of data being transferred by using EXA4MIND project. So in this particular case, we download Landsat imagery. The data is stored in NFS server. Then once the satellite imagery is there, we do cloud masking to find the scenes that are good enough for doing our calculations. They have a different block about water body detection. And then finally, we run our soil moisture content computation algorithm. The results are being stored as GIF images and as GeoJSON files. And this is what we are seeing in the user interface with the soil moisture maps. So this is how the pipeline works, and Airflow helps us to build this pipeline and track and run different steps of the pipeline, and we are going to look at it next. Now my colleague is going to show how the process of Aquaview is working from field onboarding until having the results on the platform. And I will also see how Airflow is doing it.
I'm now going to log into another account and just show how quickly is it for an end user to onboard their own agriculture land in Aquaview, and then also show what happens when a new land is onboarded. So this is the city center of Winterthur, where Terraview GmbH is located, and let's see if we can onboard a new agriculture land next to our office. So the system gives user the capability to select draw tools and then draw a boundary around their parcel to start getting an assessment of soil moisture availability on their property over a period of time. This shows how easy is it for anyone to onboard. And at the moment, only few countries are activated in the system because the data that we need to process is quite significant. So we are not able to currently offer a service on the global level. But Switzerland, Czech Republic, England, these are some of the countries which are enabled. Once you onboard a property, you give it a name, and then the command is sent to Airflow to start the initial data onboarding from USGS M2M. And here you see the status that the new plot is has started processing on Airflow. I'll show you also on Airflow. Let's see, and now you'll see that OmniDAG version 001 has one active instance of DAG running, and let's refresh it one more time, and you will see the last column is the one where the process is activated, and it's currently in the SMC process 2 stage. This process will take a significant amount of time because we are fetching data from Earth Observation Repository starting January 2013. But you can see already the initial days have been made available to the end user, and you can already see that there is a massive deviation in the retained soil moisture content over this property, and thereby it presents a nice optimization possibility for the end user. This process will continue, and when it completes, the user will be able to assess all the historical trends for the agriculture.
Okay, now we saw how the full process is working, how we can go from onboarding the fields until having the results in the platform. And we will look in a bit more details now into Airflow. So what I see here, it's the Airflow tool that we have. So that's where we run our analytics. We have several DAGs or direct acyclic graphs. Some are used in testing, and this is our production pipeline. So as you can see, it has more than close to 30,000 runs, and we have information on the last run when it happened, some recent task. If I click on this graph, so we see all the steps of this process, from searching the user, getting the area of interest, starting the DAG, going through the different steps, and then we go to the final steps of calculation soil moisture content. And here vertically we see different runs in the last 25 days. If you click on the graph here, we see that direct cyclic graph, so we can go and we can evaluate all different steps. And as you can see here, it starts from the searching user, new AI, starting DAG. It does some checks on area of interest. Then it searches for scenes to be downloaded. And once the scenes are downloaded, we are going to the step of calculating soil moisture content. And once the results are there, they will be available in the platform. There are some other monitoring things that we could see in the graph. In this particular case, we see a Gantt chart, so we can see a timing of each step and how long it took to run one particular execution. Plus, on top of it, we also see the code that is powering this Aquaview airflow DAG that we are going to look at a bit in details later. Yep. So that's the tool. That's how it looks visually, where we can monitor the processing and steps, and if something fails, we can restart the process or see the logs. Now, if you look at the code, how those things are working, so we have a Python script here that is used by Airflow, and that's the first step where we discuss the area of interest registration. We are working with Postgres database. So we need to get all the information about AOI, what kind of organization it is, which user it is. And then, well, here we see that that's the NFS locations where the processing data is stored. So, and yeah, well, here we have some access to the data to get the GeoJSONs of area of interest, etc. And another step that is most interesting for us in terms of EXA4MIND project, so it's this SMC calculation step. What we can see here that this step currently, well, in this particular video, it calls planetary computer, and it queries the Landsat data, and then it does download of all the scenes one by one, and it stores them in the local NFS database. So it uses Landsat 8 and Landsat 9 in this particular case. And what we did with EXA4MIND project, we changed the way this download of the scenes and the search of the scenes is done. So it's not using planetary computer within EXA4MIND, but it uses EXA4MIND platform, and we see more than 90% improvement in terms of the speed and the size of the downloads. Yes, so that's how the code is working. So all the information is stored in the NFS server, in the local NFS storage. And now we'll look a bit at the structure of this NFS storage. So what we have, that's the NFS structure. We have all the Landsat passes here. And for each date, we have the downloaded imagery. We do pixel analysis based on the cloud. And then we have the final TIFF files that is being used by the analytic. Afterwards, once we run the analytic for this particular date, we store the output. And the output is a hierarchical structure here. And we see that there is a date and the time of the satellite pass, and the final soil moisture calculation map as a GeoJSON and the TIFF. And this is what is used this is what is visualized in Aquaview platform. For the model, we also need to have the shapes file. So that's the shape file of the model. And we see that here we also have soil types. So this is the soil map that is used by AI model to forecast soil moisture content on the hourly basis and with depth. So this is about the file structure, and Airflow manages the pipeline of Airflow uses this data structure to store some intermediate data and the final results. So this is what we discussed now. We looked at the code that Airflow, that is powering Airflow. We looked at the scene download block, and we looked at the data structure. And that's it for today. Thank you for your attention. We presented how Airflow is used in Aquaview for EXA4MIND project. My name is Evgeny. Thank you very much.